All right, I want each of you to answer 1 through 10. I'll pause the video, and then we'll go through the answers. Okay, now that you're back, this one is a little bit confusing because B is on number 1, number 4, and number 6. So there are lots of different types of test statistics, and a z-test is only one of them. So a z-score is a version of, called a standardized statistic, and both of those are test statistics. The sample statistic is our p-hat, so that's A. Standard deviation, the variable we use is S, and the average is x bar, so that would be C. The z-score formula is going to be C. The sample statistic nope. Yeah, that's right. This is going to be A, and these two formulas are opposites of each other. So if you have, say, a weight, you can turn a weight into a z-score by taking that weight and subtracting the average and then dividing by the standard deviation. Or if you have a z-score, you can turn it back into a weight by taking that z-score, multiplying it by the standard deviation, and then adding it back to the average. So the average formula is the summation of all x's, and then you divide it by n, and this doesn't quite look right. The division should go under the square root, or under the summation, just like this one should. And then the standard deviation formula says you take every x and you find its difference from the average, square it, add them together, divide by n minus 1, and then take the square root. Okay, rest of this page. Suppose that Mr. White claims that 15% of his students think he is quite a great guy. Unlikely, but maybe. So you take a survey of 40 former students and only 10% of them claim to think so. You need to set up a hypothesis test and then use the Rossmann 1 proportion app to run that test. When you're done with number 18, move down here, and the second survey also yielded 10%, but this time instead of 40 students, there are 200. And don't go on to the back side. Just finish both of these and then we'll talk about them. Go. Okay. So, number 11, what is the null hypothesis? H naught says that pi is equal to 0.15. Now, do we want the null hypothesis to be true? And the answer is it depends, right? But the null hypothesis is always equal to every time, no matter what test we're running. The alternative hypothesis, H sub A, says pi is less than 0.15. Why did I choose less than? Our sample value was less than 15%. Is everybody good there? Okay. So, we're not paying attention here. In the Rossmann 1 proportion app, what should we enter as the probability of success? 0.15. What is our sample size? 40. So in the app, I'm going to enter 0.15. Oop, I missed the period. Okay. And then my probability, or my sample size is going to be 40. Okay. And how many samples should I run? A lot. Doesn't really matter, as long as you do a lot. So if I do 1,000, draw the samples. Okay. So there are two different ways to do this. One is we can count the number of people that say they liked Mr. White, or we can count the percentage of people. How many people said they liked me? 4. Where did you get 4? So we have the option between 4 people or 10%. You're one of the 4? 1, 2, 3, 4. The back row, nobody else likes me. So this is an important thing in statistics. Do we use the count or do we use the percentage? Now, sometimes the percentage isn't going to make sense. Like, if we are rolling a dice and adding up the number on the dice, so I get a 2 and then a 4 and then a 3, adding those up, there's no percentage, right? But if we are counting categorical data, right, this was a yes or no question. Anytime you're counting categorical data, you have the option between viewing the problem as a numerical problem or as a percentage problem. And I will let you know, percentages are always easier. When you have the choice between number or percentage, I recommend you choose percentage. It is going to create one little problem that we'll solve here in a minute, but I'm going to go through this using both types so you can see both versions. Okay? So let's do people. If we do people, how many successes did I have? 4. So I'm going to put a 4 there. And do we want greater than or less than? We want a less than symbol. Okay? And it draws the line. Oh, but I need my summary statistic because I need to answer these questions. So what is my sample value? It's either 4 people or 10%. Both are correct. Okay? What is the test statistic? This is where it gets a little bit tricky. So down here, it says that my SD is 2.25. So this SD is in people, and this SD is in percentage. Okay? So if I want my test statistic, I'm going to do 4 minus, how many people did we think were going to like me? 15% of 40, which is 6. So let's calculate that. 4 minus 6 divided by 2.25. And I get a z-score of negative 0.88. Is that an unusual value? What does negative 0.88 mean? It's to the left because it's negative. And what else does it mean? It's just less than 1 standard deviation away from the average, from the expected value. Is 0.88 SDs to the left unusual? See, this is why I struggle there, Blake.
Oh, I'm trying to figure out where you
Oh.
where your brother's just so wrong.
Oh, I'm sorry. Sorry for scolding you. Good job. Did you figure out where your mistake was? Okay, hang on. I'll pause it and come help. Okay. So if I put in 4 as my count, and I was wrong, this is the area. This is not the SD of the percentage. So here, I'm doing 4 minus 6 divided by 2.25. But if I wanted to, I could push proportion of success and enter 10%, and notice that my SD changes. So when I switch between number of successes and proportion of successes, the SD is going to change. One of them is the SD of the number of people, and one is the SD of the percentage. So here, if I take my sample statistic of 0.1 and subtract the expected value, or the null hypothesis, and divide it by 0.056, those two values are going to be the same. And this one ends up being negative 0.88, and this one ends up being negative 0.89. And they're not quite the same just because of a rounding error. So that gives us the answer to number 16, negative 0.89. And what was the p-value? So in both cases, the p-value is 27.6%. 27.6%, which means we accept H naught, and we think that the 15% sounds plausible. Now, we're not trying to figure out exactly how many people like Mr. White. This is called a hypothesis test, and we are testing the hypothesis that 15% like me. And in this case, 15 sounds plausible because our p-value was pretty big. So we're going to accept H naught and say, yeah, it sounds like 15% like Mr. White. Okay, so this is a new survey. Now we talked to 200 people instead of 40, but we got the same result as of 10%. So what would the null hypothesis be? It's the same. H naught would be pi is equal to 0.15. And the alternative? The same. HA is pi is less than 15%. So let's enter those into our app. So I'm going to change this to 200. And I'll draw my samples. Should we use number or proportion? Proportion is just so much easier. So my proportion is going to be less than 10%. Okay. So my 21 is the same, 22 sample size is 200. What is my sample value? It's 10%, 0.1. What is my test statistic? Well, I need the standard deviation. So here I'm going to do my sample value, 0.1 minus 0.15, divided by my SD, and I have to make sure that I'm in proportion. If you use the number SD, it's going to be way off. So divided by 0.031. So 0.1 minus 0.15, and then we'll divide that by 0.031. And I get a z-score of negative 1.61. So your value is probably going to be different from mine, and that's okay. The reason is we're using different curves. So you should get a number close to it, but not the same. Okay? Now, is negative 1.61 unusual? What do we consider as usual? Within 1 is usual. Okay? Now the question is this unusual enough that we're going to reject the null hypothesis? So I need a p-value. So my p-value is 3%. So in here, my test statistic is negative 1.61. My p-value was 3%. So is there evidence to suggest that Mr. White was incorrect? Yes. We reject the null because p was less than 5, and we accept the alternative. Now, are we going to make a claim as to how many people actually like me? No, that's not our job. Our job is to determine, does 15 sound accurate or not? Okay? Now, here's the important thing. Go away. Unable to drop this type of data. Okay, that was nice. This question is the important thing for today. Why did we get a different answer? Why does having more people in our sample create a smaller p-value? Okay? It comes down to this. If you want to win in Las Vegas, Should you play a lot of times or once? Once. Why? So, the house has an advantage. So, in every single game, the casino is expected to win. Oh, right. So, okay, listen up, this is important. If the expected is going to happen, it is more likely to happen if you play lots of times, right? If you flip a coin 4 times, are you expected to get 50% heads? Well, it's expected. Are you going to get 50% heads? Probably not, right? So if you flipped a coin 10 times, would you expect to be closer to 50% than if you flipped the coin 1,000 times? No, 1,000 times is more likely, and we can see that in our proportion app. So let's say we play 5 times, well, let's say 20 times. Okay? I expect to get, in 20 plays, I expect to get 3 heads, or 3 wins. Oh, sorry. Let's not play 1,000 times. So let's change this to 200. No, let's change this to 40. And then we'll only play 40 times. No, 10 times. Sorry, my keyboard is upside down. This is really hard to do. Okay, there we go. That actually came out pretty good. Did it not draw new samples? Oh, I need to. I see. I was just adding to my. Okay, so here's a coin flip. So I'm going to flip a coin 5 times once. We want proportion. Look at that. So, if you want the expected to win, you want to play more times, which is why if you go to Vegas, you don't want to play a lot of times because the casino is expected to win. The longer you play, the more guaranteed you are to lose. And we'll actually get to a point where we can calculate what your chance of winning is. It's terrible. We're not there yet. Okay? In fact, well, maybe this would be wise. Let's say when you play roulette, it's about 45% chance. So if you go and bet on red, you have a 45% chance of winning. Okay? Let's say you play 10 times. Okay? What is your chance of winning money? Holy cow. This is hard upside down. So let's do this 1,000 times. Okay? What is your chance of winning? So in order to win, you have to get 55% of the right. You have a 45% chance of winning. So if you want to win money, you've got to be right. Well, I guess we just do half the time. So let's put in 0.5. No, man, I cannot type upside down. No, it's got to be 55. That won't work. All right, so look at that. If you play roulette and bet on red 10 times, your chance of coming out ahead is 25%. Okay? But what if we play 100 times? So we change this to 100. Now what's your chance of coming out ahead? 2.6%. Still worth it? What if we play 1,000 times? So, if you bet on the roulette wheel 1,000 times, what is your chance of winning money overall? It's 0. So, some people think, oh man, I've been to Mesquite twice a year for 10 years. And then they go one time and they win $500. You have to think about all the other trips combined. The longer you play, the more guaranteed you are to lose. If you bet 1,000 times, it is virtually impossible to come out ahead. Okay? So, the next page. Oh, what do you need help with? Who needs help? Okay. I'll get them started on this, and then I'll come help you. So, the next page is going to be really hard. Okay? It's going to ask questions like, if the sample size goes up, what's going to happen? Or if the sample size is the same, and you have different sample statistics, what's going to be the outcome? So I want you to answer all these questions. We're not going to have time here in class, so I'm just going to stop the video and post it. But I want you to answer the rest of the questions and have that ready for class tomorrow. Okay?